Good morning, everyone. Am I audible?
Yes, ma'am.
Okay. Hello, now? Now just check. Hello. Am I audible now?
Yes, ma'am.
Yes, ma'am.
Yeah, fine. Okay. Yes, good morning once again. I'm actually naming this according to the textbook actually. Chapter 1 was completely about the applications. Chapter 2 is overview of graphic systems. This naming, chapter naming is based on the fourth edition of graphics, Hearn and Breaker. And we will learn about the software, computer graphics software in the third chapter. So we will see a graphic system, overview of the graphic system, or understand the hardware system, how actually it works. Just remind me at the end of the class to take the attendance, okay? 2 minutes, I think I can take it because we are maintaining the hard copy. From the system, it is taking a lot of time. I think in one or 2 minutes, I think we can finish in the class itself. Just remind me. Overview of a graphic systems. We will talk about the video display devices, input devices, raster scan systems, and then graphic software from in the chapter 3rd. So video display devices, and I mean, how are the monitors are actually set up? Because all the monitors actually gives us a graphics. That's nothing but the image and videos, right? Which we call it as a graphics. So how actually those things are designed, that we will see, which is really an interesting one. The first and basic monitor that we will discuss is CRT, that is a cathode ray tube monitor. Then we will come to raster scan displays and random scan displays. And then color CRT monitors. This is our recent monitors. This is our old monitor. So can anybody tell me, then flat panel, sorry, color CRT and flat panel, not color CRT. Flat panel is our recent ones. So do you remember this CRT monitors? Even now we have, right? Even we had TVs also, the old TVs, the previous TVs, apart from this are LCD and LED TVs. Before we had this, I think everybody would have been witnessed this kind of a TV and a computer, right? Even we actually have even a screen is a flat panel screen. But before we had like this. Hope everybody know this. This was a standard, the basic, we used to call it as a cathode ray tube monitor, CRT monitors. And when you remove this, and I still remember we had a TV like this in our older days, right? When we were small, and my dad used to open this and then he used to repair in this. All small things. He used to know just one or two things that he used to check. If he doesn't know, if it is something beyond his knowledge, then he used to take for the repair. Because I still remember we were staying in a very remote places. It's something like he was an employee in Karnataka Power Corporation, and we used to be wherever the dam constructions will be there. He was an engineer there. Where it's a dam construction, we used to be there. So it is something completely a remote places. So if any kind of a repair need to be happened, we're supposed to take it 30 kilometers away from that place. It's a remote place. Antandre, we were near the Sharavati Dam construction. So wherever the possible of locating ourselves, the complete colony, they used to make it as a colony. So near the dam, they used to make it. So it is nothing that it should be near the city, and it is some completely a remote city, and on top of the mountains, they used to construct the houses. So from there, if you want to get a repair, we're supposed to go to we're supposed to travel some minimum 30 kilometers. So obviously he used to learn all that basic things. He used to open like this. So all those repairs, basic repairs was done at home itself. So this is actually a monitor. See, this is what like this. It is here. See, it is here like this. You can see here. This part is this. And this is a CRT monitor. Now we will see how the CRT monitors are actually was working. So this is how now we are well operated. Now we have gone into the insight of the working of CRT monitors. The basic one was with respect to the magnetic deflection. Okay, let me come back to the this is a basic one. Let me talk about the next diagram and then come back to this. Okay, but later what they do, they redesigned into the electric, completely into the electric. This is nothing but magnetic deflection because we had a magnetic coils here, but that was removed and everything was based on the electricity. Everything was based on the electricity. This is a screen. This is the screen. Fine. Okay, let me talk about here. Sorry, I just forgot. Give me a minute. Let me share the video first and then let us see the working of this. Can you able to see this video?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Is this audible? Is this audible?
No, ma'am.
No, ma'am.
It's not audible. We had the same problem last time. What did we do? Now?
No, ma'am.
No.
Are loaded into three
Yes, ma'am.
Yes, ma'am. Now it's audible. Ma'am, now it's not audible.
Energy from the electron beams makes
Yes, ma'am.
How does the monitor work? Signals from your computer's video card are loaded into three electron guns at the base of the monitor. There is one gun for each of three colors: red, blue, and green. These three colors, when mixed together, can create all the colors you see on your screen. Now, these guns don't shoot bullets. Instead, they shoot a powerful beam of electrons towards the face of the monitors. The beams pass through the deflection yoke. It uses magnetism to bend the electronic beams so they can sweep across the entire screen and create the picture we see.
What happens once the beams have swept your monitor? Special chemical phosphors are painted on the inside of the monitor. Energy from the electron beams makes the individual phosphors glow either red, blue, or green, depending on the type of phosphor. The stronger the electron beam, the brighter the phosphors glow. A sheet of metal with holes in it helps keep the electron beams aligned exactly with the phosphors. This is called a shadow mask. the beams sweep across the entire screen 60 times per second. It happens so quickly that you are unaware of the firing process. Instead, your screen appears to be a steady, continuous image, just as it does now.
Okay. So did you understand it a little bit? This is the working of the CRT tube. Okay. This is quite interesting. I think now it's not audible for you, right?
No, ma'am.
Yes.
Okay, fine. I'll explain. See what is happening. Once again, I'll show you. See what is happening here. There is an electron gun here where with the help of an electricity passing through this get heated up and electrons, it gets charged up. When it gets charged up, see, this is an electricity is passing. When it is charged up, electron guns will be charged. So I'll have a this is actually a color tube. Color tube we will talk in the next class, but this is they are showing about the color tube. Otherwise, before we had a black and white. Black and white, we had only one gun. Here we have three guns, right? Three different colors of a gun. But before, what I'm teaching you today is some completely same concept, but not with the colors. So we had initially a black and white TV. So I had only one gun. Out of these three guns, I had only one gun. So this electron, this is a gun. So here in the color tube, it is a three gun. So we will talk about this later color. So only one gun. This gets charged up. When it gets charged up, thus the electrons are generated here. The electrons are generated. When the electrons are generated here, because there is a filament inside. Okay, see, there's a filament inside. This is a heating I'm generating here. Electrons is generated and electron beams are actually sent onto the, onto the screen. While sending onto the screen, you know that screen is quite a huge, it is a cube kind of a box, right? When it is a cube kind of a box, what happens? These electrons are nothing but need to be sent on the screen. Screen will have a phosphorus coated. Screen is with a phosphorus coated. Okay. When the phosphorus coated screen, when the electrons falls on the phosphorus coated screen, that point gets emitted. The light emitted, the light will be shown. Okay. But so it's nothing but the complete image. It is going, already you have seen the two times the image, right? The video. So you know that based on the electron beams, what it is passed through the phosphorus coated screen, the image is actually drawn. Currently, we will understand only that much. Now, the image need to be drawn to all complete screen, right? The screen is like this, right? It is spread like this. So when the screen is completely spread, it should be on top of the screen. So like this, I think you can see my mouse, right? The image slightly here. Now you have one image here, you have one image here. So that means the image or a drawing should be completely on the screen. I mean, all over the screen. So that means electron beam should pass to all the sides of the corners of the screen. So, but if I just leave this, what is this? Let us forget about this yellow color. What is there on top? If I just leave, the electron beam just pass straight, right? How will I move to all parts of the screen? With the help of the magnetic field here. Say this is a magnetic field. So all magnetic fields will be on four sides. One will be horizontally moved when it is charged. The other one will be moved vertically. So because of this magnetic field, that will be moved all over the screen. See, now it is vertical and horizontal. I think horizontal you can't see here. Now you see, because the beam, only based on the electron beam, the images are drawn here. Wherever the beam will be moved, there particularly on that screen, the light will be emitted. So when the light will be emitted, you will be able to see the image. Fine. Currently, we will just understand that. In deep, we will go later. So now, so I just wanted to move this electron beam to all over the screen. I will use the help of magnetic field around it to pass. Okay. So this is how. This much, let's understand now. This much is clear.
Yes, ma'am.
So this is the same thing. This is a basic one. So this is a connecting pin which connects to the power point. And then I have an electron gun here. I have only one electron gun here because this is a basic model. This is nothing but I can say it is purely a black and white. Today, whatever we are learning is a black and white CRT monitor. So now this is an electron gun. Electron gun gets charged through these pins because this is now attached to the power point, whatever it is, gets charged. This electron gun gets charged. When this electron gun gets charged, electrons will be generated. What kind of electrons will be generated here? Here, the negatively charged electrons. The negatively charged electrons are generated through this electron gun. Okay, this electron gun produces negatively charged electrons. This negatively charged electrons will pass through. While passing through, I have one more system called focusing system. Why do I need a focusing system? If I don't have focusing system here, the electrons which is coming out of this electron gun will disperse like this, will disperse everywhere, right? When it is going on dispersing everywhere, it comes wherever it finds the way. When it comes and projects the phosphorus coated, I don't get a proper image. Is it clear? So I want all the electrons. This is all individual atoms. Electron atoms is actually spread. What I can do, there will be no intensity with those individual atoms. I need to combine everything together and I want to make them, let's do undo. Okay. So as this spreads completely, the intensity I cannot produce. Fine. So I am actually making all the electrons putting together. I'm focusing them. I'm giving them a path. Please don't go here and there. If some electrons goes here, it will not come back, right? I want all the electrons to be emitted on the screen. So what I'm doing, I am using one focusing system. Okay? Just to give them a, show them a path. No, you don't have to please divers here and there. Diver, please go in this path. I'm just showing a path here. That's nothing but a focusing system. Right? It is just, that's why name itself also says it is just a focusing system. There's nothing else. I am directing giving a path to the electron beams and saying that please you have to pass through this what I can say, space itself. Only in this particular space you need to pass. They've given a passage also here. Only this much is a passage there. Now, after passing, immediately when it comes out of the focusing system, they have a magnetic deflecting coils. Okay, one on top and one on side. Magnetic deflecting coils. Again, I will teach you in clear that. So whenever electrons are what? Negatively charged, right? When the positive side of the magnet is active, positive and negative will be what? Attracts each other, right? So what this beam, now this side, it is this side because it was positive here. Now they will make positive here. What happens? The negatively charged line will now go to this part because this will move towards this side. Fine. So this is moved. Once this is done, now this will become positive and this will become negative. If it is negative, this will repel each other, and this is positive, then it attracts. So now it comes to this side. So that's why we have to show the magnetic deflection coils. Now, to just move around, to make the beam to move around the screen, all over the screen. Now, when the phosphor is, there is a phosphor coated screen on the screen. For phosphor coated on the screen. This is my electron beam. Electron is negatively charged. Phosphor coated screen. So what is this phosphor coated screen? Yes. When the electron beam touches the phosphor coated screen, phosphor coated, the kinetic energy will be generated and you will actually find the glow on that. So the light will be emitted. So when the electrons are when the electrons falls on the phosphor coated screen, the energy or a kinetic energy is released and the light will be produced there. Yes, Sahana. Any doubt? Sahana, any doubt? If there is no doubt, you can reply no. Okay. So the glow will be there. So that's the concept of electron beam and keeping a phosphor coated on the screen. Or the screen itself is a phosphor coated screen. This basic you have understood?
Yes, ma'am.
Yes,
Any doubt in this? We will go in depth. How everything is generated, everything we will go in depth. Whatever I told you now, is that clear?
Yes, ma'am.
Ramesh, is this clear? Oh my God. From your end, there is no clarity. Can you able to hear my voice properly? You can message me. I don't think you can give me an audio message. Okay. Please raise your hand if you have any doubts. Okay. So now let's go ahead now. Now, instead of magnetic field, they've slightly made the change on electron beams. Okay. Now, as usual, we have heating metal. Okay, that is a filament we have. And I have a cathode here. Cathode is what? Negatively charged electrons, right? This is negative electrons. Now, I have a control grid. What do you mean by control grid? See, control grid is completely on top. This is here, it is more clear than the previous. Immediately when cathode is here, from the cathode tube, here the electrons are getting emitted, right? So when the electrons, so here the electrons are getting actually emitted. See here, these are the electrons. When the electrons is getting emitted, immediately there is a control grid saying that, okay, I am not allowing the electrons to go unnecessary in different places and waste the electrons. I am giving them a path. Now, they are giving a focusing anode here. Focusing anode is nothing but, this is a positively charged electrons. So when you give, it is nothing but to balance that's nothing but to maintain it as an equilibrium position for balancing both positive and negative. Positive and negative. So negative will not go waste negative electrons. So for balancing, they use this. That is nothing but a focusing anode. And then next, accelerating anode. What do you mean by accelerating? Accelerating itself gives you pushing it. Accelerating is giving force. So this is again accelerating anode, because what they say here is the amount it travels from here to here, by the time it comes, there is a chances of electrons going weak, the intensity going weak. So when it is going weak, coming again on the phosphorus screen and staying here, the brightness might be reduced. So that's why they will give one more accelerating anode here, just to push it. Fine. Give a force to the electrons so that it has to, with the same intensity what it was released here in the first point, in the last point also it should be with the same intensity. So for that they have an extra accelerating node. And we have, as usual, we have a phosphor coated screen. Okay, so now this much is clear. Now, let's talk a little bit on the phosphor coated screen. So what happens with the phosphor coated screen? The phosphor coated screen, actually, what is the behavior of the screen? When a beam touches the phosphor coated screen, this phosphor coated screen, what happens? The light will be emitted. Light will be emitted. See, it will be something like this. This is your screen. This is your screen. So screen will be divided into multiple parts, right? That is actually a pixel. We will learn it later. Now I'm still in basics. I'll just give you like this. You say it is a graph sheet. Okay, you say it's a graph sheet. Now, for example, if I want to draw A, I'm just write a A. What I will do, I'll give like this. I think again I can come down slightly. And what I will do, I will mark this part. Is that not look like A? Fine. It looks
Yes,
like,
ma'am.
yes, it looks like A. Now, you assume this is a screen. This is a screen. The same thing. So on the screen, there is a phosphor coated. When there is a phosphor coated, when the light beam comes from behind, when the light beam hits on this part, this starts glowing. This starts glowing. Next, direction is changed by this field. Yeah, magnetic deflection coils. We have electric foils also. We will see later. So that means wherever it has to be moved, that movement is done. That we have taken care. So now the beam comes and stays here. This is glow. So whichever I have filled the pixel, there the beam has hit the phosphor screen. That is the areas where the beam has hit the phosphor screen. Wherever it has been hit, I have marked it as a red color, filled it. So that means for us, it is a glow, it is a light. We are talking again here, it's a black and white TV. CRT monitor. Now, these are the things where there is white color boxes. That means the electron beam has not touched there. Now, is that clear?
yes, ma'am.
Yes, ma'am.
Okay. That's how the images are actually created. That's one part. Now let me come to from the behind. Now, how do you say? Now you will have a doubt. Ma'am, how does the electron will go to that point and hit? Right? So it is purely a programming behind here saying that which are the pixels. I have a memory space separate here. Which are the pixels are zeros and ones. You know that all my drawings are, all our codes actually stores in the form of zeros and ones. So here, this complete pattern is actually sent which pixel is in the form of it. I can write it as a multidimensional array. So I will say the position 0, 0, it is 0, 0, 1, 0, 0, 0, 1, 0, 1, 0. 0, 1, 0, 1, 0. I think I should make it 1. 0, 1, 0, 1, 0, 0, 0, 0, 0, 0. I think this I should make it 1. Okay. Right? Now, when you match this and this, don't you feel that it looks similar? So that means
Yes, ma'am.
wherever, whichever the position of pixel position, you need that to be glowed. That is marked as 1. This part is actually sent as a program to this. Now what the electron beam will do it here? The electron beam is the first position. It will go reach in every, it will go touch to all part of the boxes. Now I'll talk with respect to boxes. All part of the boxes. Fine. When it is going to the 0th box, intensity is 0. Intensity is 0. What do you mean intensity is 0? Intensity 0 means, the beam is off. Okay, let me not talk about the intensity here. Let me not talk. The beam is 0. Intensity and speed. Speed is 0. So that means in this box, the beam puts 0. The beam will not go there because it is maintained 0. In this box, the beam need not have to go because beam should not touch to the boxes of 0 number. Now it is 1. Now beam should go touch to this box. So now beam will go touch to that box. So whichever the box it will go touch, it will glow. So now you are understood the scenario of this, drawing a picture. Is that clear? Any doubt?
Yes, ma'am.
Any doubt?
No.
No, ma'am.
Only 2 people? How about others?
No, ma'am.
No, ma'am.
If anybody wants me to repeat any concept, please tell me. I'm waiting. Okay. If you want to write down anything, please tell me to wait. I will wait so that you will take it down. See, all these things you will not get in textbook. Graphics is something I will tell actually too much extra so that you should understand. Otherwise, it's a little difficult to understand. So all these pictures and zeros and ones are not there in the textbook. So if you want to take it down, you can actually you can put it. So this part, screen part, you can put this part, you just write here itself. How it. So the one which comes from the program and then one which actually draws the picture. You can write both the sides. Fine. So this much you have understood now. Now the next part. I'm keep asking, I hope you have understood, right? Please again, don't, I will not disturb you. I will not keep asking you. Your own responsibility. You're all grown up kids. You're adults now. So you should be knowing your own responsibility. I really will not disturb you. I will not trouble from my side. Fine, asking questions and all those things. No. Whenever the quiz should be put up, I will put up the quiz with timings. I think I will give the quiz in class itself, giving the timings. Assignments, everything will be strictly done this time. Right? You know, principal has been changed. Principal is quite strict with all these things. He wants everything need to be done sincerely. The name I can say it as a sincerely. Fine. So we all are following the rules. So later you can't come and tell me any kind of reasons. And I don't think we will take any reasons like no data problem. No, it is your duty to set up things. Your own requirement. Colleges there open. Whoever don't have any facilities, you can always come to college, finish your things and then go back. Others, you have to find out the solution. Fine. So that reasons and all will not be taken. Whatever we give, that will be final. So from there, that side, there will be no lenient or casualty is considered. So please, only if you understand the subjects, you can actually do all the things what we give. And I don't give more time for anything nowadays. I mean, this semester. Any quiz, anything, any activities in class, 10 minutes, that's your final activity marks will be set up. Fine. Please understand. Whatever the queries you have, I will wait for that. I've told you, I'll go slow. No issues. Only thing is that you need to understand. Whatever we do, we complete the portion, that much you need to understand. If you sit silent, obviously there will be no benefit for you. It's not for me. Fine. Okay. Hope you have understood this. I'm getting only answers from 2 to 3 people. This much you have understood, right? Fine. Now let us talk about the phosphor coated screen. Now you understood. There will be an image displayed here, right? I will write a small a here. Okay, this is an A for us, right? Okay. Fine. So now we should understand about the behavior of phosphor coated screen. How does it behave? The behavior is quite different here. what does phosphor coated screen will do here is, okay, what does phosphor coated screen will do here is, the electrons, when it collides with the phosphor coated screen, or falls on the or interacts with the phosphor coated screen, this will be glow. Glow will be there, right? How long the glow is retained? That's the question mark. It is in a very short difference time the glow is retained. The glow is retained. That means the time when the electron beam touches the phosphor screen, it glows, and then immediately it will just come down. Fine. It just disappears because it's nothing but a kinetic energy is actually, it's nothing but a quantums that is actually generated there. It's a kinetic energy which is created there. Those energy will diffuse their energy. Any energy will diffuse. So you should keep on pumping them. Right? A very simple thing is, when you switch on the bulb will glow. When you switch off, bulb is off. So that means now electron beam will go. Okay, let me give a position here. To the rightmost, I'll give. Okay, this is a first position. This is a second position. This is a third position. Four. Now electron beam first. 4, 5. Okay, let me talk about it. 5, 6. Electron beam actually falls on this first position, this box. It will glow. Will electron beam will be retaining state here only? No. Electron beam will go here to the second box. When it goes to second box will be glow. Then third box. So when it comes to third box, electron beam is not in the first and second position. Correct? No. How long you expect the phosphor screen will be glowing? Can you expect it will glow? It will be glowing for the next 24 hours. No, it's simple like bulb. When you put on the light, the electricity is passed. That's why you will get a light. But when you put off, when there is no electricity bulb, the light is gone. Retaining of light is not easy without any charge. So phosphor will be retained actually compared to the bulb when electrons, negatively charged electrons, that's why we are putting the negative charge electrons here. When negatively charged electrons will collide with the phosphor, it retains for some seconds, very small amount. I don't think they have given the duration, the amount duration they have given. Oh, yeah, sorry, they've given. It's just 10 to 60 microsecond. 10 to 60 microseconds. Just in it is not seconds, it is microseconds. Only till that time, based on the quality. Higher the quality of electron, it retains for 60 microseconds. Lower the quality of phosphor, it retains for 10 microseconds. Is that clear? So now what is the solution? The image will not be retained. Now, how will I retain A for a longer time? Now you see that we are actually assume that I'm seeing a still image. Yeah, it's purely my computer. My computer, whatever the image you're seeing, that color, all these things is in electrons only. I mean, it's all the image. It's still the computer graphics. Whatever the logic I'm telling you, it's actually there here also. So assume this is my CRT monitor only. Fine. Any monitor, the concept is same. So now we are actually seeing here the image. Right? We are actually seeing the image. Now, all these, wherever you can see the color changed here, The electron beams are actually got emitted there. I mean, collided with the phosphor screen. That's why I could see the color changes. Let us forget about the color now. Say only the black and white. Now, how long? See, from past 10-15 minutes, the image is retained here. How long you are maintaining? Because the screen, whatever it is having, phosphorus screen, will not retain the image for a longer time. That means the glow will not be there for a longer time. Then what is the solution for this? Can anyone will think and tell me what might be the solution for this? How will I make the glow retain for a long time? Forget about the phosphor better quality and all. That's a better quality, best quality, 60 microsecond only. It is done. Beyond that, I can't do. What can be the other technique? Can anyone guess it? No one? No guesses. Okay. So what we will do to retain the image? So now the image for me is A. Now the beam has gone in everywhere and written A. After writing, how long it takes to write in 6, 7, 8 positions, written fast. Now the phosphor will not be staying for a longer time. But I want to keep that. The image should be safe because it's a static image, still image. It should be on the screen for a longer time. How will I keep that? It's purely nothing but we call it as a refresh rate. Refreshing. What do you mean by refreshing? Once whatever the code we have this, based on this code, my electron beam will react, right? So it is reacted here and it is passed here. Now, again in the same position, I want that to be passed because I know the image or the pixels glow will go reduced. If it goes reduced, the A will not be seen. So what I should do? Immediately I should pass this again. Perfect, perfect. So, correct, Amisha. I will use the same code to keep sending. How much speed, how often I will send this? I will set this, the rate, how it should be before it reduces the glow, before it reduces the emission of the light. The next round, the code should be sent again. Now, the beam again, it will be collided on this particular positions. Now again, I'll get glow. Now again, it will come. This is what? Refresh rate. I'll be keep calling the same program to display the same image. Is that clear?
Yes, ma'am.
Can anyone tell me what happens now? This is a still image. Because it is a still image or a static image, I am calling the same program. What happens if it is an animated image? If there is a movement?
Different set of code is being given.
Yes. Is there any other answer? Yes, the code, the different set of code will be emitted immediately first. When there is an animation, I don't have any problem because each time the code will be changed because my movement will be keep changing like this. If my movement is like this in this position, I have some pixels to be glowed so that image gets. Now next, when it comes here, some of the images points will be changed. Go like this, some of the points will be changed. Turn like this, points are changed. So every moment the code will be changing. So this much, is that clear? We will go still in depth in the next classes because we have so many things to learn here. Okay, done. Any doubt?
No, ma'am.
No, ma'am.
So now, if there is any extra things, we will be seeing this. I think we have completed everything. Intensity of electron beams is controlled by the voltage at the control grid, which, okay, there is one more intensity. So as we are talking only black and white, we don't have much to speak about intensity. When I'm seeing a black and white, black is a complete, right? White you have. Don't you have a different shades of gray here between these two?
Yes, ma'am.
We will have white and black. Say black is if I have a 1 range, white is 0 range. In between, I will have n number of ranges where it will give me gray color, right? So that means, how do you set up this? So I think even in black and white, you have seen grays also. All varieties of grays, black, dark black, slight mild black, and then changing to a gray, and then pure white, right? So that means between black and white, I think you have pretty much color, which is a combination of white and black. So how do you give those ranges? When you see a black and white, all these you will get it, right? We are not having color. When we have a color, we have a huge color combinations. Black and white also I have. So what they say here is, that is based on this control grid. He's saying it's everything depends on the control grid intensity. Control grid intensity. What is saying control grid intensity? I'll do one thing. Okay, fine. Okay, control grid intensity. Well, how does it changes control grid intensity? When the control grid intensity is high to low. In between high and low, I have again too much of difference of intensity, right? Highest and lowest intensity. In between, I'll have a middle range or lower or whatever it is. So when it is a high intensity, so that means I might get a milder. High intensity is nothing but electrons again will be generated here. Electrons again will be generated here. When the electrons are generated, even this is negatively charged electrons. Both electrons will be generated here. What will happen? It will repel. When it repels, the energy is gone there. So that means when there is a high intensity of electrons, because there will be what? Zero level of electron beam intensity. Electron beam intensity is different. Control grid intensity is different. Control grid intensity is different. Electron beam intensity reduces when control grid intensity increases. Now let us connect to this program. Which program? This. Now, in the 0th position, it is 0. The first pixel or a box, it is 0. To make it 0, what I will do, electron beam will come off because electricity filament I have given. I have a cathode here, negatively charged electrons will be coming. But how will I make it nullifying here to this position, 0 position? Immediately control grid intensity will be high. Both electrons collide each other and it nullifies the electron beam intensity to the first position of the matrix or first position of the box. So it becomes 0 there. Now, to this intensity, where it is left side, I'm writing 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Let us talk in terms of array only. Matrix, 1, 1, 1, 2. So in the position of 1, 2, row column. In the position of 1, 2, I have 0. In the position of 1, 3, I have 1. I have 1. So that means I should have an intensity there. but it is not the lowest intensity of electron beam. It should be a little bit better intensity. So that means it might be black or it might be gray. All this intensity is actually programmed, whether it should be a black or whether it should be a gray. If it is, I want to put a black here actually. If I want to put a black in the position 1, 3, 1, 3, 1, 3, I want black. Okay. Next, I will say 2, 2, I want gray. Next, highest. Okay, let me see. A middle gray, not a lower gray, a middle range of gray. You know what happens when it comes to 1, 3, 1, 3 position, it is a black. So what will be happening with the control grid intensity? It should be a low or high?
Low.
Low. It should be a completely low. That means that control grid intensity, control grid should not generate any negative electrons. So it will be completely low. When it is low, it will not collide. The electron beams will be passed and I will get black in the position of 1, 3. Now, when it comes to 2, 2, I want a gray. Now, if I want a gray, then it should be a middle range of intensity for a control grid. That intensity level also we have values. We have like what bits, whatever you have a bits, according to that bits, we have intensity bits also. Based on that, or whatever the bits is set, that much intensity is sent here. So I will get mild gray or dark gray or whatever it is. Based on the intensity set there, I will get a gray. So now you understood about the
Yes, ma'am.
color change. It is just a concept for the color change. Everything color change is based on the intensity of electron beam. But how the electron beam is controlled by a control? It is a beam. Based on the electron beam, the color actually changes. But who helps to change the intensity or change the beam color? With the help of a control grid. Exactly. Is there anybody with doubt? Anyone?
No, ma'am.
Others?
No, ma'am.
No, ma'am.
ಮೂರೇ ಜನಪ್ಪ ಈ ಕ್ಲಾಸಲ್ಲಿ ಮಾತಾಡ್ತಿರೋದು.
Ma'am.
ಪೂಜಾ, ಆಕಾಶ್, ಪ್ರವೀಣ್.
How white color it come, ma'am?
Low.
You said about black. White color you did not said. Right?
White is high. White ಅಂದ್ರೆ ಏನು? Wait. Okay.
If completely zero, you said white. Now you said it will be.
Yeah. It is again a color model. That's fine. It based on your screen. Okay, again, see, okay, I'll tell you in a simple way. Your monitor is a black screen, right? Your monitor is a black screen. So if it is black, it will be 0. However it is, it's all a programming, if you have understood this. So if you want a black, it is 0 level. If it want to white, it is a 1. Yes. So in a monitor, I think it is getting delayed. In a monitor, if you want white, andre a light should be emitted. So that means what? It should be 1. Andag enagutte? High intensity. Is that clear?
Yes, ma'am.
Now, in your what I can say, PPT or a projector, I can talk about the projector. In your projector, what is a basic screen?
White, ma'am.
When it is white in the projector, so that means your default screen, default point will be what? White. So that means what will be the value for white?
0.
Yes. What is the value for black? 1. That's all.
1.
Hope it's clear now, Praveen.
Yes, ma'am.
But the intensity concept remains same. Zeros and it remains same with respect to the zeros and ones. Any other doubt? Okay. I'm getting some of the messages. No doubts. Fine. That's about the control grid. I think we have done with all the parts. Just we'll keep going. It's what's the time? Right. So that's about the control grid. Focusing system we have already done. In a CRT forces the electron beam to converge to a smaller cross section as it strikes to the phosphor. That is a focusing beam. Okay, giving a small space. Please don't go to anywhere else. Please pass through only in this small space. That is a focusing system. Spots of light are produced on the screen by the transfer of CRT beam energy to the phosphor. That's nothing but a spot under a light. Yeah, this also we have done now. After a short time, the excited phosphor, the terminology what we use is excited phosphor. That means which produces light, glow. Fine. After a short time, the excited phosphor electrons begin dropping back to their stable ground state. So excited state and ground state, we'll say. Stable ground state, giving up their extra energy as small quantums of light energy called photons. What is generated? Photons are generated. So photons will be reducing. Light energy, we call it as a photons, right? So photons will be reducing. The light will be reducing in the phosphor. So the frequency usually we call with respect to color, because frequency or intensity we only talk with respect to the color of the light emitted by the phosphor is in the proportion to the energy. Energy andre no intensity. That is what we spoke. Yes, between the excited quantum state and to the ground state. So that means high to the low state. The color actually varies here. Persistence. Okay, just I forgot attendance, right? I'll get back and I'll just take an attendance. Be here for 2 minutes. Persistence we will talk in the next class. Give me a minute. Yes, just answer fast now. Today, what's the date? 22, right?
Yes, ma'am.
Yes, ma'am.
Sai Krishna? Not there? Himanshu? You're able to hear?
Yes,
Yes,
ma'am.
ma'am.
Yeah. Rupali? Venkata Subramaniam? Aryan? Abhishek?
Present, ma'am.
Sohail Imran?
Present, ma'am.
Aman?
Present, ma'am.
Amrita? Ankit? Arun?
Present.
Ankit is present. Huh? Okay, Arun?
Yes.
Arun is there? Ankit, I'm done. Bindu? Tejaswini?
Present, ma'am.
Chandra? Bhushan Kumar? Dev Gupta? Geeta?
Present, ma'am.
Nayana?
Present, ma'am.
Yeah, Hasib Khan?
Present, ma'am.
Kalpana?
Present, ma'am.
Harshita?
Present, ma'am.
Krishna? Krishna S. Sirakannahalli. No. Lakshika?
Present, ma'am.
Lakshmi? Lakshmi BG. Madhumati? Manoj?
Present, ma'am.
Meghana?
Present, ma'am.
Mohammed Amin? Amin. Mukund?
Present, ma'am.
Varshini?
Present, ma'am.
Naveen Kumar?
Yes, ma'am.
Amisha?
Present, ma'am.
Nikita?
Present, ma'am.
Nishant?
Present, ma'am.
Haripriya? Prajita?
Yes, ma'am.
Prashant?
Present, ma'am.
Praveen? Pushpa?
Present, ma'am.
Pushpa Bora?
Ma'am, Praveen. Present.
Yeah, Praveen. Yeah. I'm seeing. Pushpa? Pooja?
Present, ma'am.
Yes. Fine. Both of them. Rakesh?
Present, ma'am.
Yes. Hemant?
Present, ma'am.
Rekha?
Present, ma'am.
Rishav?
Present, ma'am.
Rishita?
Present, ma'am.
Roshita?
Present, ma'am.
Ramesh?
Present, ma'am.
Sahana? Samhita?
Present, ma'am.
Sanjay Kumar?
Present, ma'am.
Santosh? Sorry.
Present, ma'am.
Yeah, Santosh SV. Syed Pasha?
Present, ma'am.
Shama? Shara? Others can leave. Shobha?
Present, ma'am.
Sara is absent. Okay. Shreya?
Present, ma'am.
Siddhant? Saujanya?
Present, ma'am.
Srivatsa? Sunny Nehra? Shoaib?
Present,
Srivatsa?
ma'am.
Shoaib, okay. Srivatsa and Sunny Nehra absent. Vaishno Kumari? Venkatesh Babu?
Present, ma'am.
Yashwant Kumar?
Present, ma'am.
Manjunath DY present. Deepak Kumar?
ma'am. Present, ma'am.
Deepaka? Deepak?
Yes, ma'am.
Okay. Deepak ready. Chetan? Nandita?
Present, ma'am.
Sindhu?
Present, ma'am.
Okay, all these people can leave. If there is any extra people, you can tell me. Others, please leave.
Ma'am, Himanshu.
Huh? I answer, but don't know why you didn't hear. Okay, Srivatsa. Inside. Anyhow, next class I have here only. I'll continue here.
Ma'am, Himanshu.
Yeah, ma'am. Sai Krishna. Others leave. Sai Krishna Yadav. Which number Sai Krishna? Ma'am, that is becoming difficult, ma'am.
No, just how you're taking.
2 minutes. I'm just calling their
Calling
names.
out and there.
Hashtag. Himanshu, what is your number?
Ma'am, 1CD 17CS065. In the start, it will be on third.
Ah, yeah.
Ma'am, Rupali present.
Okay, Himanshu, Rupali present. Okay, you can leave. Next. Sai Krishna, I'm not getting. Sai Krishna, Pedini Sai Krishna, right? Okay, I'm done. 106, I'm done. Just 1 minute from first, I will come.
This is chat box.
Many of them are not able to hear. Okay. Ma'am, I'm present. I'm having network issue. Dev 18 CS 34. Huh? Yes, Dev marked. You can leave. Himanshu, I think I've marked. You can leave. Shama PM. Shama, what is your Shama marked present? Srivatsa, yeah, marked present. You can leave. I think Rupali I've done, I think. Rupali, I'm done. You can leave, then only I'll come to know who else is not done. Himanshu, Sat, Shoaib. Yeah, I'm done. Shoaib, you can leave. Sai Krishna, I'm done. Shoaib, I've done. Sunny Nehra. Sunny. Yes, Sunny Nehra. Marked present. Meghana C. Hi, you're marked, Amma. You're marked present. I think everybody's I'm done. Please leave now. Sohail Imran. Sohail Imran, what is your USN?
007, ma'am.
Marked, man. You can leave. I've done. Okay. Said Pasha, Tejaswini CR. Where are you, ma?
Ma'am, USN 28, ma'am.
Mark present. I've marked present. You can leave.
Thanks, ma'am.
Aryan, mark present. Bindu. Bindu? Bindu? Sindhu? Aryan, you can leave. Syed Pasha, mark present.